Hello, welcome to Statistics FCS 5901. Tonight we are going to be talking about testing for group differences, correlations, and t-tests. We're going to start with correlations. Most people are familiar with the word correlation and understand that it is related to relationships, and that is all that it's related to. Correlations cannot establish causality. All they can do is determine whether or not a relationship exists between two or more continuous variables. A correlation produces a number that's between -1 and +1, and the strength of the correlation is determined by how high the number is. Values that are closer to 1, whether negative or positive, indicate stronger correlations, while numbers close to 0 indicate weaker or no correlations. In social sciences, a correlation that's equal to or higher than 0.35 is considered meaningful. That means that it's considered something that we talk about. We consider this, we're not calculating statistical significance in this class for correlations on Excel. But when you have a correlation that is 0.35 or higher, we consider that a pretty significant correlation indicative of a strong relationship. And again, it doesn't matter whether it's negative 0.35 or positive, because the positivity, negativity of the correlation indicates the nature of the relationship, but not the strength of the relationship. The number is what indicates the strength of the relationship. So again, whether it's positive or negative indicates the nature of the relationship between the variables, while the number indicates the strength. A positive correlation means that both variables, the nature of the relationship is that both variables either go up in value or both go down. So at the same time, pretend these are two separate variables. They either both go up or they both go down. And I have examples to help you understand this a little bit more. But say you're looking at the correlation between GPA and drinking alcohol. So if it was a positive correlation, this means that the more alcohol someone drinks, the higher their GPA. Which really doesn't make any sense, but just for the purposes of examples, let's just talk about that. And then it would work the opposite way too. The less someone drinks, the lower their GPA. So that's if that's a positive correlation, because it's the nature of the relationship. If it's a negative correlation, as one variable goes up in value, the other goes down. Or as the first one goes down, the second one goes up. So again, taking GPA and drinking alcohol, if it's a negative correlation, it means that the less alcohol one drinks, the higher their GPA, or the more alcohol one drinks, the lower their GPA. So again, I can't express that enough. It's talking about the nature. Previously, we talked about the number, which indicates the strength. So the closer it is to the number 1, whether it's positive or negative, the stronger the relationship. And 0.35 is kind of the magic number in social sciences. In Excel, to calculate a correlation, you would use the following function: equal, CORREL, open parentheses, array1, comma, array2, close parentheses. And I will show you that in Excel. Hold on one second. I've got an example ready to go. And that is not the one. Okay, this is the one. So, and I'm going to make this available on D2L so you guys can open this as well. This is the correlation example. We have stress measured on a scale from 1 to 5, with 1 being hardly stressed at all or not stressed at all, 5 extremely stressed. Then we have age. We have gender, we have relaxation, which indicates people indicate what kind of activity they like to engage in to relax. So they select one. And there's reading, exercise, talking to others, eating or watching TV, and you can see the code book is here. And we only need the code book for gender and relax because those two are categorical variables, while stress and age are both continuous variables. You can only calculate a correlation using both continuous variables. You can't use categorical. The reason for that is because it violates a number of statistical assumptions, and because when you have categorical variables, remember you're assigning a numerical value to them. So those numbers actually don't have any meaning. But with continuous variables, the numbers do have meaning. And if we were going to calculate a correlation between stress and age, here is the function that we would use. And I'll show you how to do that from like kind of scratch, I guess. Is that what I want to say? Scratch? That's what I'm saying. Once you type in equals Corel, you can then just highlight the first array. And then add a comma and highlight the second array of numbers. And then you'll add the closed parentheses and hit enter. And that actually gives you the correlation between those two variables, which is negative 0.45. We're always going to round up to 2 decimal points. And so you would report a negative 0.45. I've also given an example of the write-up here. There is a negative correlation between age and stress of negative 0.45. This means that age and stress are related as the correlation is higher than 0.35. And I've just put in parentheses as a reminder, social sciences correlation over 0.35 is considered meaningful. And because the association is negative, it means that when one variable is higher, the other is lower. So the older someone is, the less stress they experience, or the alternate version of that same statement, the younger someone is, the more stress they experience. So it would work both ways. So that is how a correlation is calculated between the two variables. Pretty straightforward. For the most part, people tend not to have a lot of trouble understanding that. But do let me know if you do. It's important that you do understand it and know what a correlation is and how to calculate it in Excel. Okay, so here's just another example. A correlation was computed to determine if there was a relationship between drinking coffee and irritability. The correlation was 0.58, indicating that the more coffee the participants drank, the more irritability they reported. So just another way of reporting a correlation. And really, the important things to remember about a correlation are that the number indicates the strength of the relationship, whether it's positive or negative indicates the nature of the relationship, and that correlations can only be computed with continuous variables. So moving on to independent sample t-tests. It's the only kind of t-test I'm going to explain for this class because it is the most common one, probably the one that you're more likely to use. But before we get into that and how to calculate an independent samples t-test in Excel, we have to talk a little bit about independent variable versus dependent variable. Independent variables, or IV, are the predictor variables, or sometimes called the grouping variables. And they are always categorical. And when you're talking about an independent samples t-test, you're always talking about 2 categories for the independent variable. You can only test with 2. So like gender would be a common one, males versus females. what type of student someone is, undergraduate versus graduate, whether somebody prefers the color pink or whether they prefer the color black, whether they, any category, whether they like music or they don't. A lot of times there's yes, no variables that are used as the grouping variable. But the independent variable is always categorical, and it only has two categories. The dependent variable, on the other hand, is sometimes referred to as the outcome variable, and this has to be a continuous variable for an independent samples t-test. So you have your grouping variable, and basically what you're doing is you're comparing the mean, the average on the dependent variable between the two groups. So the two groups will have different means. You will be calculating that as part of this test, and then you compute an independent samples t-test to determine whether or not there is a statistically significant difference between the two. So an example, which group spends more time studying? Which the studying would be the dependent variable on a Friday night, undergraduate students or graduate students, and that would be the independent or grouping or predictor variable. So this just kind of highlights what I just said and gives you a few more examples. Again, this is called the independent samples t-test. When I think of t-test or independent samples, I think two groups, and we're testing their means. So whatever the dependent variable is, we calculate a mean for each group and then find out if there's a significant difference between the two. In Excel, the function for an independent samples t-test, and notice, you may have already noticed, but every time I use this t when I'm talking about the independent samples t-test, the t itself is small, lowercase, and it's italicized. And that's because it is a statistical symbol, so it always has to be italicized like this. So here's the function, equals ttest, open parentheses, array 1, comma, array 2, comma, the number 2, comma, and the number 3, and then close parentheses. And although we haven't dealt with this kind of formula yet in Excel, for this class anyways, the numbers 2 and 3 have to be added after the array of the numbers because they're indicating what kind of t-test is being conducted. So let's open up the handy little example that I have ready to go. And so this is looking at, here's a data set for males and females GPA. And we want to know if they are significantly different. So the first thing that we would do is insert the average and then do the same thing here, because remember we have to have the means for the groups. In our test we'll do that, but it won't give them to us in the results. And so I'm not sure why this is bold. I'm just going to unbold and make it black. And then I'm just going to highlight these so we know that these are the average GPAs for both of these groups. Now let's put in the formula to calculate a t-test, which is going to be equals CORREL, open parentheses. This is my first array. I'm going to do a comma. Then my second array, whoops, comma, the number 2, comma, the number 3, close parentheses, enter. Oh. Okay, that didn't really work, and I don't know why. Hold on one second. It may be because I didn't do a space between these. No. Okay, so I'm just going to try that over here. Oh, you know why? Oh my gosh. Okay. So this is good. This is actually a really good lesson for all of us, including me. It's very easy to type in the wrong formula, which is what I did, and that's why I'm getting this error signal. So it's actually, and you maybe were wondering why I wasn't putting this in, T-test, not correlation. So there's our first array, second array, comma, 2, comma, 3, parentheses. Okay, so that actually worked. And seriously, that really is a good example of how easy it is to make a mistake. So what this gives you is this p-value. So it computed the test, it compared the two means for the two different groups, males versus females, and then what this gave me are the results of the p-value for the test. If it's less than 0.05, it is significant, and since it is 0.006, then there is a statistically significant difference between the two means. And so what we would do is write that up. And independent samples t-test was computed to determine if there was a statistically between GPA scores. I'm just going to go back and italicize this T. The results were significant, and you're going to actually add the p-value. And when we're talking about p-value, you can actually go out 3 decimal points. So I'm going to go ahead and just put in, actually, I'm going to round that up, what the p-value was, and I have to italicize this letter P because it's a symbol, indicating that females had a higher GPA, and then you're going to want to put in what the group mean was, italicize the M, then males, and you would do the same thing. Period, go back and italicize the M. So that just shows you how to compute the test. We computed the means, we ran the test, discovered it was significant, and then we wrote up the results in APA format. So let's just go back to the PowerPoint. And I'll continue on. So you already saw me do this, calculating the mean for the dependent variable for each of the two groups. What I didn't talk about, and what you probably will have to do if you didn't do it when you entered the data originally that you collected, is you may have to create 2 new columns, one for each group, and enter the scores on the dependent variable, whatever that may be, so that you have the 2 columns like I did, because you have to calculate 2 separate means. And you have to know what those means are. When I wrote up the results, I didn't just say it was significant, I actually reported what the average was for each group, and that is part of it. Sometimes, now I've taken these same, I didn't round this up to 7 here, but I took the results of the independent samples t-test we just conducted, put the write up here, and then I inserted a figure. You guys have already practiced creating figures. This time I did a bar comparison, but you could do whatever kind of figure you wanted, but it's easier sometimes for people to understand when they can see the differences rather than just relying on numbers. And you'll note that I added the n. We always add the n. That is the sample size. So although there was 2 columns and 15 entries for each column, remember that's each square was 1 person. So it's actually 30 participants. And I just wanted to remind you about that. If you think about this, why do you have to report the sample size? Well, in statistics, a bigger sample size is always going to be better. You're always going to have more statistical power. And when you're generalizing the results, the bigger the sample, the more generalizable the results can be. So if you had a sample of 30 versus a sample of 30,000, you would probably understand that the sample of 30,000 would have more generalizability, and also we would have more statistical power to determine if there's differences. So that concludes my little lecture on correlations in independent samples t-test, and I will post a in-class activity on D2L for you guys to do to practice both of these in Excel. Okay.